Ladies and gentlemen, today we have the pleasure to have a small discussion with Dr. Vikas, who has over 3 decades of experience in the field of data science. Right. So, thank you, Dr. Vikas, for taking this time out to have this discussion to help our learners.
It's my pleasure, Apoorv. I especially like the analytics with your community. In fact, I learned many of the things from your website. Yeah, and then eventually I met Kunal. So the focus from Analytics Vidya on the genuine learning is really awesome.
That's great to hear.
Many of my colleagues use it. So,
Dr. Vikas, you've been continuously contributing to the field of AI for almost 3 decades now, right? And when you look at your career, what were some of the key milestones which defined your journey in this field?
well, so my introduction to the field was in my BTech project. So now this is very common. Right? So at the time I was doing handwriting recognition.
Oh, okay.
Right? So that's what, 1996? Oh. Right. Now, since then, the key turning points I have found are in the domains that I work in. Right? So the algorithms may remain similar, or they might change. Right? So for instance, in my graduate work, I started working with multi-agent systems for computational biology. Okay. Now, there, notice I had to learn all the biology. Although I was a computer science graduate student, I had to learn all the biology. Then I ended up, so I worked at Caltech a little bit more on that. At Intel Corporation, I had to pivot completely again because their chemical engineering, mechanical engineering, remember I'm trained as an electrical engineer. Right? So the thing that I found is being flexible about the domain that one is working with, or currently, right? Another pivot point, right? I'm doing ERP, HCM. So for those who do not know, enterprise resource planning data, human capital management data, supply chain data. Now this data, I had to go back to NCERT textbooks from class 11 and 12, which I chose not to study when I was in class 11 and 12. Right? Because I need to understand that domain as well as the practitioners of that domain to be able to solve the problems. So instead of data science, I would actually rename the area to be the science of any particular domain you're solving the problem in. Right? So I think those pivots actually helped me get a broader perspective. So now I hear more from the experts, and then based on what I hear, then we solve the problems. Rather than go out and say, give me data, I'll solve your problem.
Right. It's very interesting that you go deep into the domain that you are working on to understand the basics of it, and that helps you create better projects, better models. Right?
Yeah, I find it imperative almost, because just to even have the conversation to say, for even a customer to explain to me what their problem is, I need to understand what they're talking about.
True.
Many times they're using, especially in biology, it's like, so therefore, I felt that to some extent, one does have to learn the domain. But what I have found, the challenge I have found with that is for somebody who is in the space of computer science or data science, for them to pick up some of the domain turns out to be somewhat easier than, let's say, somebody who is a lab biologist. For them to pick up computer science is somewhat of a steeper, it depends on the individuals, but I have usually found them. So to put that expectation on the customer, that somebody who has been, let's say, a chartered accountant, some of our product managers have been chartered accountants for life. Right? Now, to expect them to learn all the depths of what we do in data science, I think it's somewhat unfair. Right. I think we need to come together to a bridge and say, let's learn some of both.
And again, continue the discussion. So sometimes when we talk to the stakeholders from the domain, right, the stakeholders won't get an idea about the things that we would really find interesting, right? We would have that model view of things. So how do you ensure that they understand what is it that we are really looking for, or the kind of information that we are looking for, which can create us a great model, right? So how does that communication structure out?
Well, so I learned this from Dr. Vishal Sikka at Infosys while I was working for him. And I got a very 15 minutes intro from him, and I think that's better than most courses people take. This is the idea of design thinking. So the conversations that I have with customers, or even external or internal customers, is around design thinking. The first thing is to figure out what is the actual business problem they're trying to solve. Right? No machine learning, no data, nothing. What is the problem you're trying to solve? Sometimes the problem may be very simple to solve. right? You don't need any technology for it sometimes, right? Now, first you figure out what is the problem they're trying to solve, and is it worth paying money for it? Meaning, are they willing to put money on the table for it? Right? Because if they are not willing to pay money on the table for it, that means they are not interested in solving it themselves. Right? Meaning, see, they may do it, they may not ask me to do it, they may not do it themselves, but if nobody is willing to solve the problem with significant amount of money, that means the problem is not important enough for them to solve. Right? So that's the number one item. So, and we may make a list of those problems. Now, we may find out that some of those problems are, quote, not solvable in the time frame we have, or with the data we have, or with today's technology we have. That's your second step, right? Feasibility of something. It's many times, customers will come up with really far out requests, and what I request them to do is, yes, that will be possible. Let's come back in 5 years, but today, let's do this. Right? So that part, and the third part is, how do you make it sustainable for the customer? See, today I can give you something that works well. And is how do you make it working next year, next geography, right? In their next department. For the same customer, it may not work in their next department. Right? So that conversation needs to happen. So now once you have identified the problem, then you have to go deep down. Then you have to look at, okay, now what's the data? Where is the data? And sometimes customers, they have data in so many different places within their own company, and one part doesn't want to share the data. They have legal issues, so many issues. So one has to actually help the customer work through that. That's another challenge for them, right? Because internally they may not be able to do it, but when an external person says, well, these need to come together to solve your problem, then it's easier for people to hear that. And that, oh, well, these guys are telling me. Exactly. So that makes it easier. Right? So that conversation does occur. But then to have that conversation, I need to, so I'll give you an example. One of my colleagues, he read up before a meeting with a pharma company. This gentleman read up a graduate biochemistry textbook in a week. Of course, that's a little extreme, I would say, right? But at least it has to be at the level as, at least, like for example, what I was doing, actually giving you an example of, I read up an accounting textbook, NCERT textbook, what to do, right? Or business management. I have not done an MBA or anything, right? But you need to know basic terminology to even, you cannot keep asking, okay, what do you mean by that? If you have a meeting, by the time you get to the actual business problem, you are only talking about definitions of things.
This ensures that you're at least talking the same language.
Yes. So, see, and that's the point I was trying to say, that if you expect a chartered accountant, right, to understand that, for example, how does a random forest work? It'll take me maybe 3-4 months for them to get it, right? But for me to understand, read one chapter in my accounting textbook, it's not that hard for me. Whereas for them to pick that up would take time. But again, there are individuals. My doctoral advisor, he was the kind who could do both.
So another interesting question is that you have worked on several different kinds of projects, right? Mm-hmm. If you have to choose one or maybe two of your favorite projects, which one would those be? And what were some of your key learnings from those projects?
So there was a time we were creating these activity context aware systems. Now the idea of activity context aware systems is, there's a concept of thing called episodic memory. So the idea is, whatever a person is doing, let's say on their desktop or laptop, or interacting with any AI system, right? So you keep a track of what they're doing, right? And not only you keep a track of what they're doing, you keep a track of what their colleagues are doing, like in the whole enterprise, right? And then from that episodic memory, you can generalize that, oh, here is the best way to do something. So for example, it takes me 9 minutes to do something, whereas it takes you only 2 minutes, because you just do things much more efficiently, or certain shortcuts and so on, right? Now my system can learn that Apurv has a best known method for solving this problem, right? So then that system can suggest to me, without naming you, that why don't you try that? We did this for a large bank where they had analysts writing reports, right? They do this routinely on different corporations, right? So now the challenge they have is, normally what they would have to do is they would have to go to different websites, pull this information, pull that information. Now, of course, you can do that, some of that, without facts with ChatGPT. But if you want today's factual information, they would have to go out. Right. right? Now, what we did was we created a system that, okay, now let's say I put in my title, right? I say financial woes of XYZ company, right? Now, what my system will do is I have different sources of information. I have Dow Jones, Bloomberg, AP News, Reuters, what have you, right? And also I have their filings with the stock exchange, all of that information. Right? Now I can pull in just that relevant pieces of information and provide that as a sidebar to the analyst, and they can pull that into their article, right? And that suddenly amplifies them. And see, this thing doesn't require knowledge work, the pulling that information. Right. That is just, you can say, grunt work, right? And I'm just saving them all that time. That's what Srikanth was also talking about. So those things I'm able to automate for them. So now the important thing here is I'm able to provide that information in the context of what they're doing. See, if I provide it tomorrow, I provide it in a separate article, not useful for them. True. In the context of what they're doing, I help them.
That's very interesting. Which year was this in?
So this was in the 13, 14 time frame. So we took this, we socialized this at AAAI, HGI, the largest conferences in AI. And many people, from different companies, from Microsoft, from IBM, so we create kind of an ecosystem around that. So now a lot of people are doing this, of course.
True. Right. And in a way, you were sort of providing ChatGPT-like experience way back in 2013.
So the difference between ChatGPT and what we were doing previously is we realized that to provide factual information, even today, by the way, to provide it in a domain-specific manner, what today you would call supervised fine-tuning. Right. Now, I'm doing supervised fine-tuning to a particular domain. Right. Now, there, I can provide you very high-quality information. But if I try to essentially boil the ocean and try to be a jack, I will end up being a jack of all trades. I will not be an expert. Right? So now there, what we were able to do is, with high confidence, provide people ability to transact even with systems, like insurance systems, with banking systems, with healthcare systems, in a conversational way.
Okay. So any other favorite projects that you would like to share some light on?
Well, it's the kind of things we are working on now, where we are trying to create AI apps which work for all our customers. Okay. Right? Now that's a challenge, right? Now the challenge we have is all of these customers have so many kinds of data. Right? Now, even within ERP, there'll be so many things. Right. Even within customer experience, there'll be so many. Now the challenge there is, how do you make your app work for every single one of those customers? It's a huge customer, it's a small customer, the data characteristics are different, how soon they need the information is different. For all of them, it has to work, it has to maintain its accuracy. This is a huge challenging problem, which generative AI doesn't solve this problem, frankly. Like, cannot solve this problem, because the issue here is not so much just information retrieval, but you're trying to actually model the world. Now, that capability we still have to build into our AI systems. Right. Today, it is still done by humans, right. Humans using computational tools. Right. So this is where I see, data scientists are not going away. And this is where analytics vidya is very important, because while there might be certain things you are able to do, for example, Databricks released this English as a programming language. So they release English SDK. Just like you have Java SDK, they release English SDK. And you can literally write comments and write code for you. But the thing is, who's going to write the comments? You need somebody. You need somebody to understand enough computer science. Right. You need somebody to understand enough data science to even command that thing. Makes sense. Right? Makes sense. So I think there's a lot of scope for learning here. And I think that's where your training programs come in. See, it's one thing to do a POC. It's quite another thing to put something in production and have it working for years. Right. Very big difference. It's one thing to write a research article, put it up on the internet or archive, or show something for social media. Oh, I did this with ChatGPT. But quite another thing to run it in production. Big difference.
And for a very customized use case, right?
Yes,
so you have to think a lot about the different kind of prompts that you want to add, yes. The kind of situations which you would want the model to be fine-tuned at. So
and it cannot, see, in enterprise, you cannot make mistakes. See, I'm not talking about the consumer use case. In consumer use case, this thing passes the Turing test, 99.9% people are happy with it, right? No issues with that. But in enterprise, I cannot have factual errors, for example. And there also there is a difference. Right? For example, ChatGPT can solve my daughter's first year computer science problems. Second year, it cannot do. So there is still a lot of scope there.
In the early days, when you started your career, computational resources weren't as readily available as they are now.
Yeah, that's true.
So how did you navigate that space? What were some of the solutions?
Well, okay. So my BTech project for handwriting recognition, that was done on a 286 machine.
Okay.
Yes, 286 machine, and I think the memory was 256 kilobytes.
Kilobytes.
Yes, kilobytes. You see, remember, I was at IIT Delhi, 1 year younger than Srikanth, right? So the total internet capacity at the time for India was 2 Mbps. Total, all. And that was shared by 5 institutions, 4 IITs and 1 IISc.
Okay.
That's it. Meaning, outside, we didn't have any email accounts at the time or anything like that. Right? So we had to write very efficient code that would fit in that memory. And for example, if you scan an image, right, you had to make sure that you were able. See, if I made it grayscale, it will take too much space. So you had to make it black and white. Right. Like just on and off. That's it.
Just one channel.
Yeah, just one channel. That's it, right? And then you have to make it the smallest possible. So see, that's why you see a lot of older material. You'll see 28 by 28 images and so on. That's the reason. So yes. See, and we were actually collaborating with SUNY Buffalo. That's where that kind of comes from. They did it for the U.S. Post Office. That's where that data set. Yeah, they did it in the 95, around the same time we were working on it. So lot of compute resources limitations, but that also made us extremely efficient. I mean, these things, they would just run just like that, right? Now, over time, what I've seen, when I worked at Intel, for example, or at AstraZeneca, we had a lot more resources there, but then we were able to do a lot more too. Right? So, and even now, right, when I'm working at Oracle, it's not that you get unlimited compute resources, right? For research purpose, you may get, but in production, right, it costs money. If a customer is going to, if my model at a customer is going to use this much resources, it's costing the customer eventually. Meaning I'm charging the customer, so for me it's good, but for the customer, it's bad. So we have to make our models as efficient as possible. I cannot just say I'm going to use GPUs for everything. I could, technically I could, right? But then that produces a burden on the customer because they have to pay for that. Right? So even if I use the GPU, then I have to be conservative in that, because if it runs across all the customers every day, it costs serious money for people. Right? And then of course I have to also be careful about model. I talked about model retraining today. Now, how often do you do it? Right? Because that costs, again, environmental costs there. Right? So yes, we have a lot more compute resources, but as I said, for research is one thing, right? But if you're putting something in production, you need to know, all of us need to know that it costs money, obviously, and it costs the environment.
And since we are talking about computing, what are your views on quantum computing? Is it something which can really transform the world of machine learning?
Well, so machine learning, I'm not so sure, but cryptography for sure, right? Because there are huge, there will be all of our RSAs and so on will be broken, right? So that is a challenge. But again, people are coming up with the quantum tolerant or quantum, not aware, I would say, quantum resistant algorithms now. Right? So now in terms of general purpose computing, which also includes machine learning, I haven't seen too much research yet, simply because the machines that are available today are not large enough to do a lot. So that I think I would say wait and see. I would love to see more research.
And so this is a question which sort of you partially answered in some of your other answers, but let's say with the advent of generative AI, right? How should a aspiring data scientist change their outlook, change their journey, or change their way of approach to be relevant?
Well, so I think the fundamentals are critical everywhere. A lot of people say you don't need math, or you don't even need to know coding. You have to know fundamental computer science. If you don't, you will not be able to figure out if what the output was given by generative AI, is it correct or not, right? Or the input-output characteristics, you have to be able to see it, right? You have to know the statistics. So if you know the fundamentals, usually you will do well, right? And if you don't know the fundamentals, meaning people who skimp out on the fundamentals, people who were like, I have seen a lot of, for example, uh, companies or groups, they have been teaching people that you don't need to know math, you can just, take this, library and, call this function and you're done. Those folks will not get jobs, right? Whereas if you see the analytics Vidya kind of training, where you go in depth, right? That, or of course, our regular educational institutions do that. Those people will be able to go through this very smoothly, right? But folks who are entirely dependent on the fact that they can write a script, that job will not be available anymore.
So should a budding data scientist rely on these tools, or should they?
Meaning the upcoming tools. Well, so see, if you are actually a budding data scientist, I would say don't just use the tools yet. Meaning, see, we are recommended to use the tools because it just makes our work faster. I can see quickly, okay, I don't have to write all that PySpark code. I can just tell this English as I'm not using it, by the way, because there are copyright issues and so on, right? Because if I'm putting that code in my code repository, right, so we have issues around that, right? So I would prefer to write it, at least in production, I would write my own. For research, you can do anything. But as far, if somebody is starting off, right, they have to write the code themselves. Don't not even copy paste, literally type it out. Right? Meaning, even if you're taking a Coursera course, analytics Vidya course, if you have not typed it out, in fact, I had an experience like that, and it was beautiful. We had an instructor on Apache Spark, right? No, sorry, PySpark, and of which of course includes Apache Spark. So there he said, so this, when you start a Spark session, right? So you have to write 4 or 5 lines, right? Now technically you could copy and paste from the previous program that you wrote, right? But he said, no, type it out, type it out, type it out, type it out. So basically it becomes your finger memory to a point you understand what's happening. Right? Now, what happens if you just generate is, when next time there's a bug in that code, you don't know what's happening. You don't know how to fix it, right? And most of the time, that is a challenge. See, it's one thing that question has been asked on, let's say, Stack Exchange, or something is there on GitHub, right? And your ChatGPT or Copilot kind of reframes it and puts it, stochastic parrots, as one paper said it. They can do that, right? Now, that works, as I said, for first year level problems. First year level problems, lead code problems, it works. Right? But in the real world, you don't get those. In the real world, you always get a novel problem, right? That is not solved on the internet. So then it may give you a solution, but you don't know whether that's what you wanted, right? So if you have to check it, you have to absolutely know the fundamentals. So do you see? Yeah.
And I was also just thinking out loud that, let's say, at this stage when probably people are learning, right, they may get into the habit of, let's say, using tools like Code Interpreter, for which you would have to upload data set. Yeah. But when they go out and work in the enterprise, they can't upload their data sets out there, right? So
well, even if so, it's possible, right, that their company may get an in-house version of a Code Interpreter, possible, right? But even then, if your code has a bug, you still have to know how to step through it. You have to know how to see the value of the variables. That is something that cannot go away, unless you can show to me that you have a code interpreter which never goes wrong, and a code generator which does exactly what I expect. See, the thing is, many times when you specify, right, when you're writing specifications for software, whether it's machine learning software or any software, the challenge is your specifications are never perfect. Even humans don't understand it so well, right? So now we are expecting that a machine will automatically understand my specifications, whatever I am thinking in my mind, which I did not put down on paper, and produce the correct code. That's just not going to happen, right? Something I have not even expressed. Right? Yeah, maybe we'll get telepathic machines whenever. I'm joking about that, obviously, right? But until that happens, right, you cannot just say, okay, I wrote down these, because in the real world, what happens? I produce something. That's what their agile framework is about. I produce something, I show it to my customer or manager or whoever is the other stakeholders, and they say, well, but that's not what I meant that. Then you go back. Of course, your machine can do that too, right? But what I'm saying is that somebody has to look at it and say, "No, is this right?" Okay, so that problem of alignment OpenAI is starting to solve, right? They have put Ilya Sutskever on that, but these are unsolved problems. So for a new data scientist to go out and think, see, there are two schools in this, by the way. One side is like, what's the point of learning all this? Now everything will be automated. That's one way, one school. The other school is, oh, it's all automated. My job will get done quickly, right? Now the problem with the first one, of course, is a problem. The second one also has a problem because you do not know how to resolve issues, and there will always be issues when you're actually delivering something in the real world. There are always issues. So if you're not a thorough computer scientist, you'll struggle. Now, see, and I've seen this at multiple companies that even you can say younger employees, right? They were very good programmers, but especially once it comes to data science kind of thing, when you really have to have understanding of data structures, you have to have understanding of linear algebra. If you genuinely don't know that, you can use other people's algorithms. But very often we are supposed to create our own algorithms, right? So when we are creating our algorithms, none of these will help you. True. Right? ChatGPT is not going to give you a new algorithm, right?
And that's a very interesting point, right? So sometimes we have to create a new algorithm from scratch, right? And over there, you need to have
no, almost always. In fact, not just once, right? Even if you have certain off-the-shelf algorithms, you still have to create, you can say, a meta algorithm which stitches them together, right? And for that, you have to know what are the characteristics of these things. What is the input, what is the output. If you don't know that, then
True. What's the right way that you need to make steps?
So one of the things that I ask in interviews is very simple. Like you take logistic regression, okay, or you take any of these deep learning algorithms. I ask, people have put everything on their resume. So the first thing I ask them is very simple, ordinary question. Okay, you have this data. Okay, so how does it look in the matrix? What is the shape of the matrix? Very simple question. I'm not asking difficult questions. Right? So how does this look? Right? And only the successful candidate, very rare. See, people have learned it superficially, but when you have to write the code, you have to know the nitty-gritty details.
Yeah, makes sense. Sometimes in data science projects, right? Let's say when you get a new client, they would probably come to you with an expectation, right? But over the course of our discussions, it may happen that apart from X, maybe Y is going to be more useful in this particular scenario.
Yes.
Any interesting scenario that happened of such type?
Well, yeah, I certainly had a very interesting one. Yeah, so this was with pharma. So there was a very, very large pharma client, one of those top 3 pharma companies. So somebody had sold them this idea that we are going to do drug repurposing. So drug repurposing is the idea that you will use the side effects of the drug as the main effect.
Okay.
Right? So for example, there are certain well-known drugs which I shall not name, which are based on side effects. Okay, so now so they had this idea. Now the customer was actually the head of oncology at that company. Now I had looked at what was proposed, and I knew that is way too, in one sense, a way too ambitious thing to propose, and on the other side, the actual solution was very weak. Meaning the proposal was big, but the thing was weak. So now it was a very difficult conversation. It's supposed to be, right? This is going to be a very difficult conversation. So let's just say the head of oncology's name is Scott. So we come into the meeting. Good morning, Scott. How are you doing? I'm having fun, Vikas. So I say, so Scott, this drug repurposing is really, really hard. Don't you think? Yes, because that's what I've been trying to tell your guys. Right? So that diffused the. So I said, but you know what we can do for you? What we can do for you is, instead of solving the whole problem, which is from a science point of view very hard to solve, right? So what to speak of us solving it, right? For you, you yourself, don't have a process for solving it. What we can do is, when you have your protein structures, right? So we can start off modeling those protein structures for you, right? Or you have these not chemical equations. So you have these drug metabolism and pharmacokinetic studies, right? I can help you create models for that, and we can put all your data together in one place, so you can create models on top of that. So the thing is, that is what they actually needed, right? Now we were selling them the moon. What they actually needed at the time was just a house to live in. So they were very happy to do that. Yes, that is something I know you can do. Meaning Scott said, yeah, I know you can absolutely do that, and we absolutely need it. So many times we have to, this has happened many times, because sometimes people are taken in by the hype. So yeah, there was another one. There was an insurance head of an insurance company, a CEO. He says, I think I mentioned this in my talk, that he says, okay, I have an iPad, and let's say you're the insurance agent, I'm the customer, and the iPad is listening to our conversation, and then it automatically recommends what happens, meaning what I should purchase.
Whether the customer would buy or not, or whether the customer, what is it that the customer is going to buy?
What should the customer buy? What's the recommendation, right? So I said, that's really nice, right? But then, do you have the internal processes to enable that, right? Will you give me all your data? And he said, well, I thought AI was supposed to figure it out. I said, yeah, AI can figure it out, but then to figure out, I need all your rules and policies. And for many insurance companies, that's secret. It's trade secret, right? So they said, then I said, okay, but you know what we can do for you? What we can do for you is, we can create a tool for the insurance agent that, based on the input they get from the customer, we can find an optimized policy for that customer. That we can do for you, right? We can also create a chatbot for your customers, where they can give their requirements in steps, meaning instead of automatically figuring out from the conversation, right?
There will be specifically directed questions.
Specifically directed questions. So then it can build a story for you, right? So that is something they were quite happy with that, actually. Right? Although somebody sold them, but they said, yeah, that's all I wanted, and they're happy with that.
No, so that's very interesting, and the kind of communications that we have with these clients, right? And almost always results to do something to do with data, as you mentioned over here as well. Yes. Very interesting. Yeah. So, as a final question, data science continues to impact industries worldwide, right? What do you think are some of the upcoming exciting possibilities with the field of data science?
Well, so generative AI is an interesting one, right? And a lot of people are talking about the consequences of that. Now, one of the things I see with the natural language processing pipeline part is that the natural language processing pipeline will become much easier with the generative AI, because, for example, problems of sentiment classification, or problems of just topic classification or translation, a lot of these problems become much easier, and you can get answers with high confidence. Right? Now, these used to be the weaker part of the pipeline previously. Right? Now you can say, well, if I have an in-house generative AI model, I'm using that word, I shouldn't use generative AI, I should say large language models. Right? So, whether you have a base model, foundation model, or a fine-tuned model, or RLHF version of the model, depending on what problem you're trying to solve, I think those pipelines used to be very rickety previously. I expect those to become very robust. And what that will do is, for example, we have a lot of enterprise data that is in text form. Now, previously, you had to build a custom pipeline for each type of case. In the good old-fashioned AI world. Now you don't have to do that, right? You can say, okay, here is this text, I can ask questions about it in context, right? So that is something that's going to become very mainstream, right? Now, the other thing that a lot of people have not yet paid attention to is that the traditional sort of machine learning data science story is continuing to be very important. Why? Because yes, you can, for example, today you could tell a generative AI system that I need for you to give me an overall algorithm which does this, right? And it can string them together and make it work, right? But when you're going to put it in production, you'll have to figure out. I think there was a question in my talk about exactly this, that one of them breaks, then what do you do? So you will have to either you have to make the generative AI intelligent enough, so which may happen in a couple of years. I think I'm expecting that the generative AI is trained further with RLHF and with supervised fine tuning to a point where it can figure out those issues, or you may have to do the prompting to figure out those issues. So now to do that prompting, you have to know. So it underscores my previous point that as these advances go on happening, when you're creating these pipelines, you have to know what's happening at each step. Yeah. So data scientists are going to be around for a while, and analytics vidya is going to be around for longer.
That's great news both for us and our audiences and our learners as well. But thanks a lot for taking our time, and the last answer was a resounding success for both us as well as our learners. So thank you, Dr. Vikas. Thank you for taking our time for this discussion. It's going to be very beneficial for our learners.
It's a pleasure to be here.
No, but thank you again. Thank you for taking out this time. Thank you.